Hello, listener. Tonight's journey takes us to the farthest edge of existence. Not to a place, but to a question. What happens when the universe runs out of stories to tell? We'll drift through theories where time slows to stillness, where stars vanish without a sound, and where the last memory fades not with noise, but with peace. It's not about fear, it's about wonder, about accepting that even the vastness above us has its own kind of sleep. If this kind of thought brings you comfort or curiosity, feel free to like and subscribe. Only if it feels honest. And tell me in the comments, where in the world are you listening from, and what time is it for you right now? At this point, close your eyes, relax, and open your mind. Let's fall gently into the quiet. This is Echoes of Infinity. There's a strange kind of comfort in knowing how things end. Stories, after all, are made complete by their final pages. Without an ending, a story lingers, shapeless, unsettled, as if waiting forever for something that never arrives. But what if the story we're living in, the one written in stars, galaxies, atoms, and time, doesn't end the way we expect? Imagine a clock. It hangs in the void, suspended in silence. There are no ticking hands, no sound, no forward motion, just the suggestion of time. Etched numbers on a face that no longer means anything. This is one version of the universe's future, a time without time, an ending not with a bang or a flash, but with a slow, quiet exhale into stillness. The universe in all its noise and brilliance is temporary. We know this not from prophecy or poetry, but from physics, from entropy, from dark energy, from the subtle red shifts in light that tell us everything is stretching, drifting, cooling. All signs point to a truth both humbling and strange. This cosmos, so full of motion, birth, explosion, gravity, and light, will not last forever. And so we begin, not with certainty, but with questions. This is not a video full of answers. It's a space for thought, for stillness, for letting the biggest ideas brush against your mind like wind over water. You don't need to solve the end of the universe. You only need to feel its weight and shape and wonder what it means that such an end exists at all. Physicists have been trying to glimpse the future of the cosmos for decades, maybe centuries. Some look forward with math. Others look inward with thought experiments. And occasionally, they all arrive at something truly unsettling. Not because it's violent or dramatic, but because it is quiet, inevitable, and almost beautiful in its indifference. We now know the universe is expanding. This isn't just a poetic observation, it's a measurable, observable fact. Light from distant galaxies stretches as it travels toward us, turning red as space itself grows. What was once close is now far, and what is far will eventually disappear entirely beyond our observable horizon. That fact alone is profound, that we are surrounded by things we will one day never be able to see again. The stars we chart now may eventually vanish, not because they die, but because the space between us and them becomes too vast for their light to reach us. It's almost romantic, isn't it? A universe that says goodbye slowly, not with explosions, but with distance, with forgetting. This expansion is what gave birth to many of the theories we'll explore in the rest of this video. The idea that everything is in motion, and that this motion is not random but governed by laws, patterns, and trends, laws that suggest eventual outcomes. Some of those outcomes are slow fades, some are catastrophic rips, but all of them share one feature in common. They end the universe as we know it. And most of them do it without malice, without even intention. They happen because they must. What's truly unnerving isn't that the universe might end. It's that it might not notice us at all as it does. But before we step into the details of the heat death or the elegance of the Big Rip, let's return briefly to that clock, still hanging there, motionless in your imagination. It doesn't need hands to remind us of time, because we carry the awareness of time within us. That awareness is both a burden and a gift. To be human is to know that things end. To be cosmic is to accept that they may end without you. And in that space between knowing and accepting, we find the emotional core of this entire journey. Because as we move through each theory, we're not just studying physics. We're listening for echoes, echoes of our own impermanence, echoes of silence waiting to begin. Still, there's something strangely soothing about the idea of an end that doesn't come in fire and fury, but in silence. A gradual unwinding, like the final notes of a symphony that fade rather than crash. The quiet kind of ending, the kind we rarely expect but somehow understand instinctively. This is why so many people find peace in the concept of the heat death of the universe. It's the most widely accepted scenario among cosmologists. It doesn't involve dramatic destruction or cosmic warfare, just a long, patient decline. Galaxies drifting apart, stars burning out, particles ceasing to move, energy flattening until nothing can happen anymore. It's a vision of the universe not as a battlefield, but as a candle that slowly burns down, flickering gently until there's no flame left to give. But before we get there, we need to understand why so many of these theories, whether peaceful or unnerving, come from the same question. What is time doing? We live our lives moving forward, moment to moment, A to B to C. But physics doesn't always see time that way. In fact, the laws that govern motion, gravity, and quantum mechanics don't always care which direction time is flowing. They can be reversed, and the equations still make sense. So why, then, do we feel time only going one way? This is the riddle known as the arrow of time. It's not built into the laws of physics, it's built into us, or more precisely, into entropy, the tendency for things to go from ordered to disordered. You can scramble an egg, but you can't unscramble it. You can shatter a glass, but not reassemble it by accident. Entropy always increases. That's the only real reason we feel time moving forward. Now apply that to the entire universe. The Big Bang? The most ordered state imaginable. Everything tightly packed, clean, simple, and uniform. Since then, entropy has been increasing. Systems breaking down. Stars burning out. Galaxies spreading. Complexity rising, then flattening. If this trend continues indefinitely, if entropy increases forever, the universe ends in maximum disorder. Nothing left to do. No energy gradients, no usable heat, no structure, just cold, just silence, just stillness. But even in that stillness, something persists. Space, maybe time. And in some of the strangest theories we'll touch on later, even thought. Because an end isn't always what it seems. Some endings leave room for new beginnings. Some contain paradoxes. And some, like the ones we'll explore next, feel more like transitions than conclusions. As we move forward, keep that image of the clock in mind. Not as a symbol of doom, but of perspective. The universe doesn't owe us a dramatic finale. It may simply continue doing what it's been doing all along. Changing form, losing heat, expanding into silence, and maybe inviting us to listen as it does. What's perhaps most humbling about contemplating the end of the universe is realizing how little say we have in the matter. Our daily concerns, our conflicts, our victories, our ambitions, are all bound within a tiny sliver of space and time. We exist on a small, cooling rock in a cosmos that is not hostile, but rather indifferent. And yet, in that indifference, we discover something remarkable. Not despair, but peace. The peace that comes from seeing ourselves clearly, not as rulers of the universe, but as witnesses, observers, temporary sparks of awareness given a momentary window to marvel at everything before the curtain falls. It is not a sad story, not if you view it in the right light. Imagine reading the final page of a beautiful novel. You don't grieve because the book ended. You cherish that it existed at all. The universe may never know we were here, but we know. And perhaps that is enough. In the next segment, we'll begin our descent into the theories themselves, starting with the one that many scientists consider not just possible, but likely. It's not violent, it's not explosive, it's not fast. It's called the heat death of the universe, a future where everything we know becomes less, not destroyed, but drained, where energy becomes so evenly spread out that nothing interesting can happen anymore. No stars, no heat, no movement. Just a gentle, permanent equilibrium. We'll walk through what that means, how we know it might be happening, and what it feels like to imagine a future that ends, not with a scream, but with a whisper. So take a deep breath. Let the thoughts settle in your mind, not to scare you, but to stretch you. Imagine a room filled with children running, laughing, shouting, each one bursting with energy. The room feels alive, full of motion, heat, sound. Now slowly dim the lights, turn down the music. Watch as each child tires one by one. The room grows quieter, cooler, still. Eventually, all that remains is silence. No movement, no sound, no play, only the memory of motion, the trace of warmth fading into nothing. This is how the heat death of the universe begins, not with cataclysm, but with calm, and it ends with everything leveling out. The concept is deceptively simple. It emerges from thermodynamics, the same laws that govern how your coffee cools when left untouched. or why a hot pan doesn't stay hot forever. The second law of thermodynamics tells us that entropy always increases in a closed system. In plain language, that means energy spreads out, differences disappear, and disorder increases, always. Now scale that law up. Not to a coffee cup, or a kitchen, or even a planet, but to everything, the entire universe. The heat death scenario imagines a cosmos so old that all stars have burned out, all black holes have evaporated, and all matter has decayed into subatomic particles. But even then, there's still energy, just not in a useful form. It's evenly spread across the vast, expanding void. There's no more potential, no more gradients, no more imbalance. And without imbalance, nothing moves, nothing happens, nothing can. In the present-day universe, everything runs because of differences. Hot and cold, light and dark, dense and empty. Stars shine because there's fuel to burn. Black holes grow because gravity pulls in matter. Life exists because chemical reactions release energy. But when entropy reaches its maximum, when everything is the same temperature, the same density, the same bland silence, nothing can do work anymore. The universe won't be destroyed in a bang or collapse. It will fade into thermodynamic uniformity. This future is often called the Big Chill, and it's currently the most widely accepted fate of our universe. Not because it's the most exciting, but because the math supports it. As our universe expands, accelerating thanks to dark energy, it is stretching space itself. Galaxies are rushing away from each other faster and faster. Over billions of years, even the closest galaxies to us will move beyond our cosmic horizon, vanishing forever from view. Eventually, stars like our sun will die. White dwarfs will cool. Neutron stars will fade. Black holes will remain, devouring what little matter is left. But even they aren't eternal. Stephen Hawking's theory of Hawking radiation suggests that black holes slowly leak energy and will eventually evaporate too. What's left after all of this? A dark sea of subatomic particles spread thinly across unimaginable distances. Every particle evenly spaced at near zero energy. A universe that hasn't ended in a bang or flame, but one that has lost its spark. No new stars, no new galaxies. No possibility for complex life or meaningful structure. It's a kind of cosmic retirement. You could call it peace. You could call it silence. You could call it death by stillness. But some physicists push this further, because if the universe reaches a state where everything is balanced and entropy is at its maximum, does that mean nothing ever changes again? Maybe. Or maybe something strange begins to happen. There's a curious idea hidden in the math of thermodynamics called fluctuation. Even in a system with maximum entropy, statistical fluctuations can still occur. Think of it like this. If you shook a giant box filled with sand long enough, once in a while, the grains might randomly settle into the shape of a small castle. Not because the box tried to build a castle, but because, given infinite time, strange order can arise by pure chance. Some scientists believe that in the distant reaches of heat death, quantum or thermal fluctuations might give rise to temporary pockets of low entropy, perhaps even forming new universes or random disembodied consciousnesses. This is where it gets eerie. Imagine a moment in the farthest future. There are no stars, no galaxies, no structure left at all. But somewhere in the endless darkness, a brief, microscopic fluctuation takes place. A patch of space suddenly finds itself just a little denser. Not because of intention or design, but because randomness has no limits in eternity. This is where the concept of the Boltzmann brain comes in. Proposed by physicist Ludwig Boltzmann in the late 19th century, it's one of the most unsettling consequences of extreme thermodynamic thinking. If given enough time, infinite time, a universe in heat death could randomly assemble for just a moment something as complex as a human brain, complete with temporary consciousness, memories, and even the illusion of a full life. And then, it disappears again. Just a lonely brain, floating in space, hallucinating reality for a flicker of time before vanishing into nothing. Why is this idea so disturbing? Because if the universe really is infinite, and time stretches forever, it would be statistically more likely for you, yes, you, to be a temporary Boltzmann brain than a naturally evolved being on a habitable planet. After all, it's far simpler to randomly create a single brain than it is to construct the entire observable universe we live in. And yet, here we are, not floating brains, but embodied beings in a structured world filled with planets, people, meaning. So, is the heat death theory wrong? Or are we wrong about what's probable? This is why the heat death isn't just a physical theory. It's a philosophical and existential crisis. If the future is eternal stasis, punctuated by rare flickers of chance, then reality itself becomes deeply suspect. How do you know the world around you wasn't just assembled this moment as a temporary fluctuation? How do you know your past ever happened? Of course, most scientists don't take the Boltzmann brain idea literally, but they take it seriously enough to explore what it says about the universe. It raises a bigger question. If heat death is our future, and this long, slow fading is inevitable, what is the point of anything now? But perhaps that's the wrong question, because from another view, the heat death offers something rare in cosmic thinking. A gentle ending, not fire, not chaos, not annihilation, just quiet, just balance. No struggle, no noise, no suffering. A universe at perfect rest. And in this sense, heat death becomes less of a horror story and more of a lullaby for the cosmos, like a record that played its music, vibrated with life, and then slowly spun to a stop. The song ends, not with a crash, but with a whisper. To understand just how complete the heat death would be, we have to think about the fate of information itself. In our universe, every particle, every interaction, every flicker of motion carries a trace, an imprint. Physics, especially quantum mechanics, tells us that information can't truly be destroyed. Even black holes, once thought to erase everything they consumed, are now believed to encode what they absorb in subtle quantum ripples along their surface, what Stephen Hawking and others described as black hole holography. But in a heat-dead universe, those black holes are gone, not just dormant, evaporated. Through a process known as Hawking radiation, they slowly bleed away their mass, photon by photon, until all that's left is flat, empty space. It's not fast. A black hole the mass of our sun would take 10 to the 67th years to vanish. But it happens. Given enough time, even the most monstrous singularities dissolve into a fine mist of radiation. And once they're gone, the information is smeared thin across the vastness. Technically, it might still exist in the entropy of the universe, but it is unrecoverable. Like burning a book, and then trying to reconstruct it from the rising smoke and scattered ash in the wind. In that landscape, there are no books, no memories, no atoms held together. Protons decay over time, a prediction from grand unified theories, meaning the very building blocks of matter aren't eternal. They become loose clouds of leptons and photons, drifting through ever-expanding space that stretches faster than the speed of light. The temperature of the universe asymptotically approaches absolute zero. Not instantly, not rapidly, but with slow, icy certainty. Every remaining particle finds no partner to bump into. Every potential action remains unrealized, and that's where it stays. You might be wondering, why does this idea feel so unnerving, even though it's calm on the surface? It's because heat death doesn't end with a bang. It doesn't offer us narrative closure or cosmic punishment. Instead, it presents a deeply alien concept, a universe where nothing happens forever. Not a pause, not a dreamless sleep, but eternal neutrality. In every story we tell, there is change, movement, conflict. Heat death denies all of that. It's not destruction in the way we typically understand it. It's worse, for there's no rebirth, no reorganization, no cycle, only stillness. Some theorists offer comfort in the form of speculative physics. Perhaps quantum fluctuations could restart the cosmos, or maybe multiverse collisions will bubble into new big bangs elsewhere. But those are guesses, possibilities stacked atop unknowns. For now, heat death remains the front-runner among scientifically accepted fates of the cosmos. A final chapter with no punctuation. A universe that did its job, told its story, burned bright, and then faded into gray. But here's a twist. What if the silence of heat death is the real voice of the universe? What if all this noise, this era of galaxies, consciousness, and activity is the rare exception? What if we're the brief crescendo in a cosmic symphony that mostly plays silence? Segment 3. The Big Rip, Tearing the Fabric of Time. In the beginning, there was expansion. From the first spark of the Big Bang, the universe began to stretch. Not like an explosion outward, but like the slow unfurling of a vast cosmic fabric. Galaxies drifted apart. Space itself expanded between them. It still does. But what if that expansion isn't slowing? What if it's speeding up? And worse, what if it never stops? Welcome to one of the most unnerving possibilities in cosmology, the Big Rip. It starts with dark energy, the mysterious force driving the accelerated expansion of the universe. We don't know what dark energy truly is, only that it behaves like a repulsive pressure, pushing galaxies away from one another at ever-increasing speeds. And if that energy continues to intensify, or if its equation of state falls below a particular threshold, it won't just push galaxies apart. It will tear apart the very structure of reality itself. It sounds like science fiction, but it's rooted in real math. If dark energy increases with time, something called phantom energy, then the expansion of the universe won't just continue. It will become so extreme that eventually it will overwhelm all known forces. First, galaxies will lose their grip, then solar systems will unravel, then planets will be ripped from their orbits. Eventually, even atoms, yes, atoms, will be torn apart. Time and space will no longer be able to hold themselves together. Now pause here for a moment. Imagine what that feels like. Not as a distant cosmological event billions of years from now, but as a lived moment. You're standing in a familiar place. Maybe your room, maybe a forest, maybe on a quiet beach. You look up and the sky has begun to distort. Not from smoke, not from clouds, but from stretching. The stars are moving away faster than before. You try to breathe. Gravity no longer keeps you tethered. Your feet feel loose. The molecules in your body begin to resist each other. Everything you know begins to unzip, not in an explosion, but in a slow, eerily silent tear. Because that's the most terrifying part of the Big Rip. It's not violent in the way we're used to. There's no bang, no fire, just an inexorable, escalating unraveling. The very physics that hold your existence together become less stable, like a computer program glitching before your eyes. And there is nothing to stop it. If this is how the universe ends, it will be both beautiful and horrifying. The final seconds will be measured not in cosmic time, but in fragments of seconds. The Earth might disappear in the last minute. The atoms of your body might be the very last to be separated, ripped not by a force outside of you, but by the very expansion of space itself. And in the final moment, silence, absence, a blank canvas where once there was everything. In this vision of the end, it's not fire or judgment that comes. It's separation. Not by wrath, but by an indifferent stretching that no god could halt once set in motion. Yet the question inevitably arises, could such an end be part of a divine design? Or does it in fact confirm our cosmic loneliness? There's a strange divinity in the idea of a universe expanding forever. One might see it as the breath of God, exhaling the cosmos wider and wider until nothing remains but space and memory. Is it creation moving endlessly outward, or a great unmaking? Ancient texts spoke of fire and floods, of endings and apocalypse, but none imagined this, a slow death in silence, not of punishment, but of physics. No judgment, just math, no salvation, just momentum. And yet for some, this makes the moment more sacred, because if there is no divine intervention at the edge of time, then every second now carries the weight of meaning. Each breath is a defiance against final separation, a protest against the inevitable entropy that waits, not with malice, but with certainty. Consider the human body. It is held together by electromagnetism and atomic bonds, relationships that have endured since the birth of matter. But in the final seconds before the Big Rip, even these familiar ties will dissolve. The space between your atoms will expand. Your cells will split apart, not by injury, but by expansion itself. You won't feel pain. You may not even know it's happening, but you'll disappear, not in fire, not in cold, but in absence. Cosmologists estimate that should the Big Rip occur, galaxies will be torn apart roughly 60 million years before the final moment. Solar systems disband 3 months before. Planets shatter 30 minutes before the end. Earth, should it survive that long, would break apart just 16 minutes before the final instant. Human beings? If we still exist, we will cease in the last 10,000ths of a second. One breath, one blink, one moment. And then, nothing. And here, theology begins to squirm. What does it mean to believe in a loving creator who watches stars being peeled apart by dark energy? Or does this very narrative reveal something about the absence of a personal God? A clockwork cosmos, set spinning and then left to unwind? Or maybe, just maybe, this end is not the end. In some spiritual traditions, destruction is the beginning of rebirth, the universe, like a snake, shedding its skin. In Hindu cosmology, cycles of creation and destruction are endless. Universes die, only to be born again. Perhaps somewhere in the dark, beyond even the rip, something waits. A renewal, a silence before a new voice speaks. But that is speculation. Faith, perhaps. Philosophy. Science can only follow the numbers, and the numbers lead us to a moment where time, space, and matter no longer behave as we know them. Imagine standing in the final seconds of a universe destined for the Big Rip. Not standing on Earth, long gone, but floating, disembodied, as everything dissolves into velocity and separation. Galaxies that once burned with ancient light now stretch like candle wax across a canvas of dying space. Here, words like before and after lose their usefulness. Time collapses under its own weight. Sequence unravels. The laws that built stars and molded planets no longer apply. In a final ironic twist, the very constants of nature, those dependable foundations of reality, are the last to go. Not through rebellion, but through obedience to expansion. Everything goes where it is pulled. No resistance, no protest. One could almost call it peaceful, if not for the terrifying stillness of it. The quiet is not gentle, it's total. It's not that sounds are muted, it's that the structures required to carry them, air, atoms, vibration, have vanished. All communication ends, all observation becomes impossible. There are no eyes left to witness, no minds left to think. And still, in this terrifying oblivion, there's room for awe. For those who dare to think cosmically, the Big Rip does not have to be a tragedy. It is, in a strange sense, a mirror. It reflects back our need to find meaning, our hunger to be more than just dust that forgets itself. It asks, what would you do if you knew every bond would one day come undone? How would you live knowing even gravity would one day walk away? Some might turn to religion, seeing in this end a metaphor for spiritual transcendence. Others might find comfort in embracing nothingness, not as failure, but as a release. A final exhale of a cosmos that lived long enough to create creatures that wondered how it all ends. Even Einstein, who resisted the idea of an expanding universe at first, may have understood the poetry in such an outcome. In one of his letters, he famously said, "The most incomprehensible thing about the world is that it is comprehensible." The Big Rip would be a final act of incomprehensibility, a return to the unknowable. But before that moment, before the ultimate tearing, there is still time. Time to wonder, time to speak, time to love and to fear, and to record our little truths in trembling voices. Time even to tell stories like this one. Stories that echo like whispers into a void that may never answer back. And maybe that is enough. In the quiet corners of theoretical physics, there is a fear unlike any other. Not a fear of fire or collapse or even heat death, but of betrayal. Not of gods or men, but of reality itself. This fear has a name: false vacuum decay. Imagine this: everything you know, every law of nature, every constant, every principle, is built atop a precarious foundation. The universe, as stable as it seems, may not be in its most stable form. Instead, it may be perched in a false vacuum, a local minimum of energy, not the true ground state. To understand this, think of a ball resting in a shallow valley. From the ball's point of view, it is at rest. It does not know that a deeper, more stable valley exists just over the next hill. But one day, without warning, a quantum fluctuation, or worse, an intentional high-energy experiment, might give the ball just enough push to roll over the edge. And when it falls into the deeper valley, it doesn't fall alone. It takes the entire universe with it. This event would not be like an explosion. It would be a rewriting. A new bubble of reality would form at the point of transition and begin expanding outward at the speed of light. Inside that bubble, a universe with different physics, different particles, different chemistry. No stars, no atoms, no life, just new rules that no longer care for what came before. and you would never see it coming. The vacuum decay wave would arrive silently, faster than anything could warn you. One moment, you're sipping tea under the night sky. The next, there's no sky, no you, just absence. What makes this terrifying is not just its suddenness, but its legitimacy. This isn't the stuff of fantasy. Some versions of the Higgs field, the field responsible for giving mass to particles, allow for this very scenario. And in 2012, when CERN discovered the Higgs boson, physicists began whispering again about vacuum instability. It's not that it will happen tomorrow, or ever, perhaps, but it could. And worse still, we'd never know if it had already started. The wave could be racing toward us right now, and by the time it reaches Earth, we'd be gone before neurons could fire. It's the ultimate cosmic betrayal. The universe gives birth to consciousness, lets it grow, evolve, ask questions, and then says, oh, by the way, none of this was permanent. The rules were just placeholders. It evokes a kind of existential vertigo, a sense that even our deepest understanding of the universe may rest on shifting sands. And yet, even this horror is a kind of beauty. There's something almost poetic in the idea that we live inside a lie, not a conscious one, but a physical mirage. The laws of our universe, which we treat as sacred, may be conditional, fragile, a set of temporary guidelines until the true nature of reality asserts itself. Physicists use the term metastability to describe this condition. Imagine a ball again, resting in a dimple on a slope. It's not moving, and it seems stable, until the slightest shake or shift rolls it into a much deeper well. Our universe may be in that dimple, caught in a false vacuum, with the true vacuum waiting, silent, inevitable, below. But why would such a betrayal even be possible? Why would the universe allow for the possibility of tearing up its own blueprints? Here, science begins to flirt with philosophy. Is the universe indifferent? Are we simply artifacts of a temporary configuration of fields? If so, why does it feel so permanent, so ordered? This is where God enters the dialogue, not as a savior or destroyer, but as a question. If there is a God, is this false vacuum a feature or a bug? Did a creator plant the seeds of its own undoing? Or are we in a reality where gods, like particles, are just local phenomena, real only because our current physics permits the belief? This touches the heart of Leibniz's question, why is there something rather than nothing? And more daring still, why is there this something and not another? If a true vacuum exists, then somewhere in the potential landscape of all possible universes, another something is more fundamental than ours, more real, more eternal. Could we be dreaming physics? That thought alone has shaken more than a few scientists and philosophers awake in the middle of the night. And what of the human condition in a universe with a trapdoor? There's no preparation for vacuum decay, no shelter to build, no evacuation route. There's something chilling in that realization. All our mythologies, our flood stories, apocalypses, fires, and ice imply survival or divine judgment. But vacuum decay offers no judgment, no symbolism. It is utterly devoid of intent. Yet, strangely, this terrifying possibility can bring peace. If everything could end in an instant without pain, without warning, without struggle, doesn't that simplify things? You no longer need to fear a slow decline, a long goodbye, a drawn-out cosmic entropy. The end becomes a clean erasure, a perfect silence. Some have called this idea the quietest death in the cosmos, and that's what makes it so unsettling. It's not the violence of vacuum decay that unnerves us, it's the utter absence of signs. No tremor, no flicker in the stars, no darkened sky. Just a bubble of true reality expanding at the speed of light, rewriting physics behind it. You wouldn't even have time to perceive its approach. One moment, your atoms obey quantum laws, and the next, those laws no longer exist. And you do not either. To grasp how this works, imagine the universe as a field of dominoes frozen in place. Vacuum decay is like tipping a single domino, not one you can see or predict. But once it falls, the rest follow instantly, not in a row, but in a wave, erasing the rules that held them upright in the first place. We're used to thinking of change as something observable, sunsets, seasons, the passing of time. But this change hides from observation. It creeps not forward, but everywhere, all at once. That realization brings us to another unsettling implication. We might not be the first version of the universe. Some theoretical physicists propose that our universe could already be a descendant of previous false vacuums, that is, prior universes that underwent vacuum decay, spawning new ones with slightly different laws. This gives rise to the notion of a multiverse, not just as a collection of parallel realities, but as an evolutionary tree of existence itself. And in this tree, some branches die instantly, some mutate and flourish, and some, like ours, live just long enough to ask dangerous questions about their roots. Why do the laws of our universe appear so finely tuned for life? This question, known as the fine-tuning problem, has haunted cosmologists and theologians alike. The strength of gravity, the mass of the electron, the ratio of matter to antimatter, alter them ever so slightly, and stars wouldn't form, chemistry wouldn't function, and life would be impossible. Is this fine-tuning evidence of a designer, a god, or simply the outcome of anthropic selection? We observe a universe tuned for life because we are alive to observe it. But if vacuum decay is real, this tuning may be a temporary illusion. The cosmos may have stumbled into a state that happens to support our existence, but which has no promise of permanence. And here's a sobering thought. If the true vacuum is more stable, more real, then in some bizarre sense, we are the dream. And one day we will be awakened, not by choice, but by contact with a deeper truth. Some philosophers compare this to the death of God, not in the Nietzschean sense of cultural loss, but as a literal cosmic deicide. If reality can collapse into something with different laws, what becomes of the God who reigned over the old rules? Does such a God vanish with its universe? Or does it live only in the frame of laws we now know? Vacuum decay is the quiet end of theology. There is no final trumpet, no fire, no judgment, just a silent transition to a universe that might not even know we were here. And yet, there's something sacred about the false vacuum, not because it will destroy us, but because it ga. Everything we've ever loved may be balanced on the edge of a precipice we can't even see. In this light, the false vacuum isn't just a scientific theory, it becomes a philosophical parable, a quiet reminder that certainty is borrowed, not owned. The stability we cling to, our laws of motion, our constants of nature, even our own existence, may all be the consequence of a temporary lull in a far greater unfolding. This isn't despair, it's clarity, the awareness that existence is conditional, and that makes it radiant. Every breath, every sunrise, every child born into this world, they are all miracles of a metastable moment. When we sleep, we expect to wake up in the same universe. Vacuum decay suggests this expectation is only true until it isn't. What do you hold on to when the universe itself has no ground floor? Maybe that's where the human spirit enters. In the face of unseen obliteration, we still write poetry. We build telescopes, we search for beauty, we fall in love, we construct meaning, not because we know the universe will last, but precisely because we know it may not. This awareness echoes ancient philosophical dilemmas. Stoics spoke of accepting fate, amor fati, the love of one's fate, not because it is fair, but because it is. Buddhists speak of impermanence as a gateway to peace. And existentialists like Camus remind us that rebellion isn't found in control, but in our attitude toward the absurd. Vacuum decay, then, becomes a modern myth, a scientific metaphor for the transience of all things. It is the death knell of permanence and the anthem of now. But there's a strange piece here, too. A bubble expanding at the speed of light is not malevolent. It doesn't hunt. It doesn't hate. It just unfolds. Like a truth too vast to conceal, too indifferent to warn. And from a certain point of view, that kind of end is beautiful, because we will not hear it, we will not panic, we will not suffer, we will simply no longer be, like a dream dissolving upon waking, unaware of its own departure. And in that silence, perhaps something else begins. Another reality, a new symmetry, different constants, different creatures asking different questions under alien skies. Maybe somewhere in that next iteration of existence, the echo of our universe lingers, not in memory, but in the possibility that something once existed and dared to ask what existence meant. Segment 5. The Cosmic Breath, the Bouncing Universe Theory. Imagine the universe not as a line with a clear beginning and end, but as a breath, an inhale and an exhale, stretching across billions of years. This is the heart of the bouncing universe theory, a concept that defies the finality of the Big Bang and the despair of heat death. Instead, it proposes a rhythmic cosmos, one that contracts and expands in eternal cycles, like a chest rising and falling in sleep. It's a strangely calming idea, isn't it? In this model, the universe doesn't end. It resets. When everything collapses into a dense singularity, perhaps not unlike the one that sparked our Big Bang, another explosion follows, birthing a new cosmos with fresh potential. It's a cosmic recycling system on the grandest scale imaginable. There's something oddly human about this theory. We breathe, we sleep, and wake. We fall and rise. Why wouldn't the universe do the same? The elegance of this idea lies in its defiance of finality. Death, in this view, is not an end, but a pause, a gathering of all things into a silent, compressed moment before the next beginning. And it reframes our fears. We no longer face a future of endless cold or inescapable collapse. Instead, we exist within an eternal heartbeat, long and slow beyond comprehension, but steady. Science lends some weight to this vision. In certain models of quantum gravity and loop quantum cosmology, space and time themselves may possess the properties needed for this bounce. The singularity that ends one cycle could, through quantum mechanisms, trigger the expansion of the next. And the entropy, so feared in the heat-death model, might be recycled, reset, or somehow transcended at the bounce point. But even more fascinating than the physics is what it means for meaning. In a bouncing universe, time has no origin, no ultimate destination. It just is, an infinite loop. Some thinkers compare it to Nietzsche's eternal recurrence, a philosophical idea that whatever happens has happened before and will happen again, endlessly. But unlike Nietzsche's vision, which was existential and deeply personal, the bouncing universe feels impersonal. It's not a punishment or a challenge. It's simply the nature of existence. And within that nature, the question arises. If the universe bounces, do we bounce too? Not we, in the literal sense of our bodies or names, but perhaps in patterns, thoughts, civilizations, even stories. If the initial conditions of the cosmos remain similar with each bounce, could there be echoes of us in every cycle? Are we fated to rise and fall again and again in infinite variations? Or does each bounce birth a cosmos so different that nothing remains the same? Not even the laws of physics? You lie back with that question pressing softly against your mind, and a strange calm settles in. Because no matter the answer, the idea soothes something primal. The universe never really ends. Now picture this. Between each cycle, between each collapse and rebound, there may exist a liminal moment, a silence, a stillness, not unlike the pause between heartbeats or the fraction of a second between a deep breath in and out. In that gap, there is neither space nor time, no atoms or stars, just possibility, a void brimming with potential. To us, such a moment would be unknowable. There would be no observers, no clocks to measure its duration, no remnants of the previous universe to carry forward memory or identity. And yet, philosophically, it beckons. An in-between space that invites comparison to mystic traditions and spiritual metaphors. Some ancient philosophies, particularly in Eastern thought, speak of cycles not only in nature but in existence itself. The Hindu concept of kalpas, for example, describes long cosmic periods, epochs of creation and destruction, that repeat endlessly. In a strange way, the bouncing universe theory is science catching up with myth. But modern cosmologists are cautious. The bounce isn't yet proven. The mathematics is complex, and many models still face problems, particularly around entropy. After all, if entropy always increases, how can each bounce lead to a fresh start? Wouldn't the universe become more and more disordered with each cycle, eventually making bouncing unsustainable? This is where cutting-edge theories like loop quantum gravity come into play. In these models, space-time isn't smooth and continuous, but granular, made up of tiny, discrete units. Like the pixels in a digital image, they form the fabric of everything. And in this quantum geometry, the singularity at the center of a collapsing universe might be avoided entirely. Instead, it reaches a minimum size and rebounds, carrying the laws of physics into a new expansion phase, perhaps with new constants, new dimensions, or even altered fundamental forces. And here's where theology and philosophy quietly re-enter the room. If the universe resets, if it bounces with variation or randomness each time, what does that say about intention? Is this pattern the result of blind mechanics? Or is there something, or someone, that chooses the rhythm? Is the universe just a machine with an infinite spring? Or is it a breathing mind, dreaming itself into being again and again? Some thinkers might say that's where God hides, not in miracles, but in repetition, not in interruptions of natural law, but in the law itself. A divine heartbeat that pulses across eternity, uninterested in our names or prayers, yet present in the cadence of everything. Others, more skeptical, may argue that this very idea of an eternal bounce renders any God unnecessary. What needs designing if it all recycles naturally? Either way, the image remains. A cosmos inhaling and exhaling, stars collapsing inward like lungs releasing breath, only to explode outward again with new light. If we follow this metaphor further, the inhale and exhale of the cosmos, it invites us to wonder, is time itself breathing? Is causality not linear, but cyclical, caught in a rhythm we only glimpse from the inside? To live in a universe with a heartbeat suggests we're part of something more organic than mechanistic. It gives the cosmos a pulse. This idea was explored by physicist Richard Tolman in the early 20th century. He proposed a model in which the universe oscillates endlessly, expanding, contracting, bouncing again and again. But he ran into the same trouble as modern physicists: entropy. Each cycle, he argued, would increase the amount of disorder. Over enough time, the universe would lose the energy needed to bounce back, leading to a slow, final death, like a breath that never comes again. That concept is unsettling, a loop that ends, a bounce that weakens. But not all models agree. Some theorists suggest that entropy could be reset, or even reversed at the bounce. Others propose that time itself reverses during the contraction phase, effectively unwinding disorder before the next expansion. These are still speculative, but tantalizing. They challenge our deepest assumptions about what time even is. What if time has no arrow, only a curve? Now consider this twist. In a bouncing cosmos, we may never truly be us again. Each bounce may give rise to entirely new laws of physics, with no memory of what came before. A new cosmos might not allow atoms to form, or stars to ignite, or perhaps life arises, but not as we know it. In one bounce, there may be no carbon. In another, consciousness may emerge as plasma clouds instead of neurons. This renders the idea of reincarnation, or even repetition, strangely moot. You don't come back. Nothing does. Not exactly. It's not a cycle of return, but of reinvention. And yet the pattern continues. From a philosophical perspective, this creates a tension between familiarity and alienation. The universe repeats, but without repetition. It's like a melody where the rhythm remains, but the notes are always different. For some, that's terrifying. There is no eternal return of the self, no persistence, no accumulation of memory or karma. You are a momentary shape in an eternal sea, never to be seen again. For others, it's beautiful, a kind of cosmic humility. We aren't here to last. We're here to pass through, to shimmer briefly in the breath of infinity. And just as dreams dissolve when morning breaks, each universe collapses into the next, with no one left to remember the dream. This cyclical cosmic drama of collapse and resurgence raises deeper, more spiritual questions. If there is no final death, no fixed beginning, but an eternal pulse of universes emerging and fading, then what does this say about purpose, about creation, about God? In many philosophical traditions, cycles are not a sign of despair, but of rhythm, of harmony. The Hindu concept of Brahma's breath, for instance, envisions the universe as exhaled into existence by the divine, only to be inhaled once again after untold aeons. In this view, creation is not a singular event, it's a cadence, a sacred beat, a breath of the divine. Is modern physics, by accident or design, stumbling upon the poetry of ancient cosmologies? Of course, scientists don't speak of gods, but metaphors sneak in. They speak of birth and death, of rebirth and memory. They speak of the universe as though it were alive, pulsing, renewing itself. And in doing so, They echo voices from temples and texts thousands of years old. Now imagine a universe so vast, so ancient, that each bounce contains the seeds of not just a new reality, but new laws of existence. Perhaps in one iteration, intelligence cannot form. In another, it flourishes in crystalline lattices or gaseous thought clouds, drifting through solar storms. Each cosmos is a sketch drawn with different pencils on the canvas of possibility. This places you here and now in a very strange position. If our universe is one iteration in an infinite chain of breaths, then you are a fleeting product of a single exhale, a shape made by cosmic air, a ripple in the great lung of existence. But far from meaningless, this can be deeply grounding. You are not separate from the cosmos. You are its articulation. You are what the universe is doing now. And when it breathes again, it will do something new, something different. And somewhere, perhaps not here, that version of existence will also wonder what it all means. There's a strange peace in that. Maybe we don't need permanence. Maybe we don't need to matter forever. Maybe being part of the breath is enough. So as you lie here tonight, thinking of the cosmos, inhaling and exhaling through time, imagine the silence between those breaths. Imagine the stillness before the next reality stirs, that quiet moment when everything pauses and becomes nothing. And then, everything again. Would you want to be there, in the space between worlds? Or would you rather dissolve, like a sigh, into the dark? The bouncing universe doesn't give us answers, but it gives us rhythm. It gives us motion. It gives us the breath. And tonight you are part of that breath, rising, fading, dreaming. Imagine a candle burning in a sealed room. Over time, the oxygen depletes, the flame flickers, and the warmth it once radiated fades into stillness. Now scale that image to the size of the entire cosmos. That's the essence of the heat death of the universe, a chilling, poetic theory about the ultimate fate of everything. Unlike the fiery drama of a big crunch or the rhythm of a bouncing cosmos, this ending is quiet, cold, final, and somehow deeply unnerving. Physicists call it thermodynamic equilibrium, a point when all energy has been evenly spread out across space and there's no more flow, no gradients, no movement, no structure, just a vast uniform nothingness where temperature differences no longer exist. In essence, the universe would become incapable of doing anything. Think of a wind-up toy, slowly unwinding. At first, its gears spin with purpose, but eventually the spring loosens, the energy dissipates, and it comes to a stop. The toy is still there, physically present, but its vitality is gone. Our universe, according to this theory, is like that toy. In the far, far future, trillions upon trillions of years from now, stars will burn out. Black holes will evaporate through Hawking radiation. Even the subatomic particles that make up atoms might decay. Galaxies will vanish into darkness, and what's left behind is an ocean of low-energy photons drifting through endless, structureless space. A place without contrast, without noise, without story. A place where time, in a strange way, loses its meaning, because nothing ever happens. And here's the twist. This theory is widely supported by entropy, a principle at the heart of thermodynamics. Entropy measures disorder, and in a closed system, it always increases. The universe is the ultimate closed system. So over time, order must dissolve into chaos. Not explosive chaos, but the kind that smooths everything into sameness. It's the ultimate flattening. No spark, no motion, no surprise, just stillness. As we drift deeper into the implications of the heat death, we start to feel the weight of cosmic isolation in its purest form. In this far-off scenario, even the concept of memory fades, not because minds are gone, but because nothing remains to hold or generate memory. Consciousness, should it somehow still exist, would be like a flickering signal in a sea of static, pointless, unanswered, unanchored. There will be no witnesses, no stories, no after. It's a curious irony. The most terrifying end is also the quietest. Unlike cataclysmic collapse or explosive expansion, the heat death is peaceful, eerily so. It's the kind of peace that unnerves, like walking into a room that's just a little too quiet. No ticking clocks, no breeze. Just stillness so complete it becomes almost loud in its absence. And from a philosophical standpoint, it forces us to confront the idea of permanence. In religious traditions, there's often a promise of eternal life or a divine cycle. In mythologies, the end of the world leads to a rebirth, but the heat death offers no such resolution. It's the end of all potential, not just all life. A state where even the gods would be silent, not because they've disappeared, but because the cosmos itself has no stage left for their existence. So what does it mean to live in a universe headed toward this kind of ending? Does it strip life of its meaning or sharpen it? Some thinkers, like Bertrand Russell, faced these kinds of cosmic conclusions with stoicism. He famously said that only on the firm foundation of unyielding despair can the soul's salvation be built. That line has echoed through many a sleepless night, reminding us that perhaps awareness of cosmic futility is not a reason to despair, but to live more fully. And there's something oddly freeing about it. If everything ends not with a bang, but with a whisper, if the universe gently falls asleep forever, then we, brief sparks of consciousness, are anomalies in the cold. And that makes our moments of love, struggle, joy, and insight not less important, but far more precious. They are unrepeatable flashes in the dark. And in those flashes, those shimmering moments of awareness, we find what may be the last rebellion against entropy, meaning. Because even if the universe trends toward disorder, the human mind works in the opposite direction. We build order, we seek patterns, we connect memories, emotions, hopes, fears, and we create art, music, philosophy, all in defiance of the silent thermodynamic doom that awaits in the end. In that sense, contemplating the heat death becomes a mirror, not of destruction, but of creation. We look up at the stars and recognize that we are watching them burn their time, slowly marching toward stillness. But as long as we are watching, there is still wonder. There is still consciousness moving against the tide. What a strange beauty that is. That life is not a static monument in the cosmos, but a spark thrown against the winds of decay. This brings us back to a profound question. If nothing lasts, is it still worth doing? Nietzsche would perhaps respond with his idea of amor fati, the love of fate. He might argue that meaning does not require permanence. Instead, meaning emerges precisely because things are fleeting. We value a sunset because it fades. We value life because it ends. The heat death, then, is not the enemy of purpose. It's its background canvas. Now let's shift focus a little and zoom in further. What would it feel like to live during the final breaths of the cosmos? Would it be like growing old in a home, where the lights dim slowly, where voices grow quieter, where neighbors move away and are never replaced? A cosmic hospice, where the universe waits not for rescue or renewal, but for closure? Some physicists suggest that in the far future, intelligent civilizations, if any survive, might try to preserve consciousness for as long as possible. Slowing their computation, stretching energy use to its most efficient limits, perhaps spacing out thoughts across thousands of years just to keep the lights on a little longer. It's a humbling idea that at the edge of time someone might think a single thought and then wait 1,000,000 years to think the next. The universe would not end in fire or ice, but in waiting, an eternal dusk of the mind. Imagine for a moment that you're walking through a vast cathedral. Time slows to a breath. You reach out to touch one of the pillars, and before your fingers connect, the pillar stretches just slightly away from you. You move faster, but so does the retreat. The marble cracks, the arches bend, and then the entire structure unravels into silence. That is the unsettling vision proposed by the Big Rip, a cosmological theory suggesting that one day everything in the universe, from galaxies to atoms to spacetime itself, may be torn apart by the accelerating expansion of the cosmos. Unlike the heat death, where everything cools into stillness, the Big Rip is violent, active, unforgiving. It begins with the observation that our universe isn't just expanding, it's accelerating. Distant galaxies aren't drifting. They're being pulled from us faster and faster, like leaves swept downstream by an invisible current. This is due to a force known as dark energy, a strange pressure woven into the vacuum of space that pushes everything apart. Now, what if dark energy becomes stronger over time? Not just persistent, but aggressive. Eventually, its repulsive force could exceed the gravitational pull that binds galaxies, then solar systems, then planets, and finally, molecules. In this scenario, about 60 billion years from now, the Milky Way would dissolve. A few million years later, our solar system would fall apart. Earth, the Moon, and everything we know would be torn from orbit. But it doesn't stop there. In the final minutes, the force becomes so immense that it overpowers molecular bonds. It shreds cells. It rips apart atoms. Even quarks, the smallest known building blocks of matter, would be flung apart into nothingness. The fabric of space itself would stretch until it breaks. And then, silence. No lingering glow, no echo, no afterimage. Just nothing. The terror of the Big Rip lies not in a bang or a burn, but in the inevitability of unmaking, like pulling a thread from a sweater until all that remains is loose yarn. It's a theory that takes the expansion of the universe to its most logically extreme conclusion, suggesting that not even the laws of physics are safe from cosmic acceleration. But how do we arrive at such a dramatic ending? It starts with an important value in cosmology known as the equation of state parameter, denoted as W. This number determines how dark energy behaves. If W equals -1, dark energy remains constant over time. This aligns with the classic cosmological constant model. However, if W is less than -1, dark energy grows more potent, more forceful, and more volatile. In this case, it leads us straight into the Big Rip. This kind of dark energy is called phantom energy, a name that suits its ghostly, unknowable nature. Phantom energy doesn't just push galaxies apart, it grows stronger as the universe grows larger. The more space there is, the more phantom energy there is to pull that space apart. The math is terrifyingly elegant. At first, things seem normal. The galaxies drift away, stars live and die, and life continues. But over time, the distances between objects grow at an exponential rate. And then, the bonds that hold everything together, gravitational, electromagnetic, even nuclear, fail one by one. Unlike other end-of-the-universe theories where destruction comes from without, a collapse, a freeze, a burn, the Big Rip comes from within. It is existence turning on itself, a rebellion against cohesion. Let's pause here for a moment. Because if everything is destined to fly apart, what does that say about permanence? About meaning? About memory? Do we comfort ourselves with the illusion that some record of our lives will remain? That somewhere, a signal will echo? That entropy may take its time, or that we may leave a fingerprint. The Big Rip denies that comfort. It says, nothing stays. Not space, not time, not thought, not even particles. And yet, nestled in this terrifying image is something strangely peaceful. A surrender, a final breath, a universe exhaling one last time and letting go. Imagine a countdown, but not in seconds, in milestones of cosmic disintegration. Let's say the Big Rip is scheduled to occur 22 billion years from now, according to some projections. Roughly 60 million years before the rip, galaxy clusters begin to drift apart faster than gravity can keep them together. The night sky loses its pattern, its familiar constellations. A lonely hush falls across the cosmos as entire galaxies become unreachable. Light simply can't travel fast enough to bridge the ever-widening space. A few months before the end, stars are pulled away from orbiting planets. The solar systems unravel. Earth, if it still exists, will no longer be gently circling the sun but drifting alone until it too is torn from within. Minutes before the Big Rip, gravity fails to hold Earth together. The crust, the mantle, the core, ripped asunder. Milliseconds before, atoms are destroyed. Electrons separate from nuclei, quarks flee protons, and the building blocks of matter are shredded. In the final instant, even space-time collapses. There is no where left to go, no when left to remember. The universe doesn't explode or fade. It's pulled apart so completely that even the concept of apart loses meaning. There is no observer left to describe it, only the possibility that once, long ago, something existed here. Now let's step back. The philosophical implications of the Big Rip are deep. It is not just a scientific model, it is a confrontation with impermanence at its most radical. Some ancient philosophers, Buddhists, Heracliteans, Stoics, already held that everything changes, everything flows, everything passes. The Big Rip seems to be their prophecy made cosmological. It's as if the universe itself is a practitioner of impermanence. In that light, the rip isn't a tragedy, it's a truth. a reminder that even gods and galaxies dissolve. But that thought needn't lead to despair. If nothing is permanent, then nothing is ever truly lost. Every moment lived, every connection formed, every act of love or discovery shines more brightly against the darkness. It matters because it passes. And so we're left with a paradox, a beautiful and haunting one. The universe may end not with a crash or a freeze, but with a quiet unweaving, an unraveling so complete that it brings not pain, but peace. Imagine a world where nothing changes. No stars, no warmth, no motion, just an infinite stillness spreading in every direction. This isn't a frozen void in the classical sense. It's something much stranger. It's not cold like ice. It's cold because everything that could have happened has already happened, and now, nothing remains to move. This is the haunting premise of the heat death of the universe, a scenario where, given enough time, the universe reaches a state of maximum entropy, the ultimate equilibrium. All usable energy has been spent, all gradients flattened, all light absorbed. Nothing left to power a star, no spark to light up another mind. It's eerily fitting that this segment opens with silence, because heat death is the triumph of silence over sound, stillness over motion, sameness over difference. To get here, let's look at how the universe works. From the very beginning, the Big Bang, our universe has been expanding and cooling. Stars formed, galaxies spun, black holes collided. Life, at least on one small planet, emerged to witness it all. But entropy, this subtle, relentless force, has been growing all the while. Every moment of activity, every transfer of energy, pushes the universe closer to balance. And balance, paradoxically, is the death of novelty. Think of a cup of hot coffee in a cold room. Over time, it cools to room temperature. The temperature difference, the ability to do something useful like heat your hands, is gone. Now imagine that principle applied to everything. Galaxies, stars, atoms, even radiation. No temperature differences, no usable energy, just a vast, uniform haze. That's the heat death. But here's the unnerving part. According to current physics, this isn't just possible, it may be inevitable. Even dark energy, the mysterious force-driving expansion, may only accelerate our path there. Stars burn out, black holes evaporate, matter decays, until what remains is a thin, dim smear of photons stretched so far across space they're practically non-existent. And time? Time becomes meaningless when there's nothing left to change. Some theorists describe heat death as the ultimate meditation of the cosmos. A state of perfect stillness where no further action is possible because every possibility has been exhausted. Not by catastrophe, not by sudden annihilation, but by the slow whisper of time smoothing out the wrinkles of creation. No bangs, no collapses, just the hush of entropy completing its work. It's unsettling to think that the same thermodynamic rules that govern your coffee cooling or your body losing heat in the night also govern the fate of all galaxies. The same principles that make an engine work or a cell metabolize energy also predict the stillness of all things. That's the power and horror of entropy. It's not loud, it's quietly inevitable. What makes this theory more disturbing is that it doesn't rely on exotic physics or speculative strings. It stems directly from what we already know. The second law of thermodynamics, in simple terms, says that entropy always increases in a closed system. And what is the universe, if not the largest closed system imaginable? There won't be a moment when someone says, "It's happened." No trumpet blast, no cosmic flash, just the slow disappearance of difference. The lights go out, one by one. Stars like our sun will die, leaving behind white dwarfs that cool to black. Neutron stars too will go dark. Even black holes, those titans of gravity, will evaporate by a strange quantum process known as Hawking radiation until they too vanish. And then, nothing. A universe with no complexity, no structure, no temperature gradients, no observers. Maximum entropy means there's no more work to be done. Time loses meaning because nothing happens. Every moment is the same, forever. But isn't there a paradox in that? If time becomes meaningless in such a state, does the universe still exist in time? Or does it enter a new realm of non-existence through stillness? This invites strange questions. Is heat death death at all? Or is it a new kind of existence, an eternal sleep? like a monk dissolving into meditation so deep they no longer remember what they are? What if this isn't the end, but a threshold to a state of pure potential, an empty canvas, not a burned one? Some thinkers, particularly those influenced by mysticism or metaphysics, suggest that heat death resembles nirvana, not an ending, but an end to craving, to struggle, to identity itself. Is this the end of the story, or the falling away of the story altogether? Imagine for a moment you could travel billions upon billions of years into the future. You'd pass beyond the death of your sun, beyond the last star in the Milky Way, beyond even the slow fade of cosmic background radiation. What would you see? Not darkness necessarily, but a featureless absence, a gray, thin void where temperature is uniform and everything has run its course. Every process that once generated heat, life, or change, every star formation, every black hole merger, every flicker of matter transforming into energy, will have already happened. The universe will have become the same everywhere, in a final and perfect equilibrium. That may sound peaceful, but peace here is not warmth, not kindness, but a mechanical silence where the engines of reality have shut down. This future isn't a dramatic collapse. It's the opposite. It's a prolonged whimper, the slowing of everything. Even subatomic particles, if they survive, will dance slower and slower until they simply exist in place, motionless, not because they're bound, but because motion is meaningless. There's no temperature differential to encourage flow, no light, no dark, just stasis. But stasis poses philosophical challenges. Can you call something existing if nothing about it can ever change again? If no event distinguishes one moment from the next, if even time stops flowing, is that still reality? Or is the universe, in a way, already gone? There's a haunting beauty to this idea. In some mythologies, the cosmos begins and ends in silence. In others, silence is the source of creation. In the heat death, silence is the destination. The universe may not die with a scream, but with a sigh. And here we can't help but think of human parallels. People crave meaning, and meaning often arises from contrast. Joy because of sorrow, purpose because of struggle, clarity through confusion. A universe in heat death has no contrast left. It cannot teach or inspire, for it no longer contains anything dynamic. No change means no evolution, no difference, no story. Is this why we resist the idea so much? Not because it's painful, but because it's too quiet, too final. It offers no stage for rebirth, no narrative arc, no redemption, just the final symmetry of all things. Yet some physicists suggest even heat death might not be permanent. There are quantum fluctuations, the idea that even in the emptiest space, particles may spontaneously appear and disappear. Could something emerge from nothing again? Could a spark flicker in the vast cold? The odds are astronomically low, but given infinite time, perhaps. In this view, heat death is not a period at the end of the sentence. It's an ellipsis, a pause, a breath held for eons. Others challenge that view, arguing that the laws of thermodynamics remain insurmountable. Once maximum entropy is reached, the universal ledger closes. The book is written, bound, and shelved, eternally unread, because no reader remains. To understand why heat death strikes such a chord, not only with scientists but with philosophers and poets, you have to grasp its quiet cruelty. It is not violent, not fiery, not explosive. It's utterly indifferent. It is the consequence of every star burning out, every atom cooling, every black hole evaporating. No agency, no malice, just inevitability. Unlike apocalyptic images of fire or flood, there's no clear villain here, no cosmic rupture. Instead, entropy plays the slow role of patient sculptor. Entropy doesn't destroy in the way we imagine destruction. It smooths, dulls, equalizes. It takes the jagged and the vivid and flattens it into the same. It doesn't tear down the cathedral. It erodes it grain by grain until one day it is indistinguishable from dust. Now let's take a philosophical detour. Ancient Stoics believed in cycles, worlds burning in fire and reborn. Eastern cosmologies often hinge on reincarnation and renewal. But the idea of an unrepeatable ending, a one-way street to oblivion, challenges those comforting loops. If the universe cannot restart, then perhaps meaning doesn't emerge from cycles. but from the finiteness of things. This is what makes the heat death more chilling than even the Big Crunch or a vacuum collapse. It offers no spectacle, no reversal, no second act. And if that bothers you deeply, you're not alone. Friedrich Nietzsche's notion of eternal recurrence comes to mind here, but twisted. Instead of repeating existence endlessly, what if we confronted the eternal stasis, a loop not of events, but of nothingness? Time becomes irrelevant. The universe becomes a canvas that can no longer be painted on. Not even blank, just inert. And in this vast dormancy, we start to ask spiritual questions. What becomes of soul, of memory, of intention? If consciousness requires energy gradients, requires difference, how could it persist in a sea of sameness? Does this final state render God irrelevant or more necessary than ever? One view suggests the heat death proves a universe without inherent purpose, its destiny driven by statistics and thermodynamics. Another sees in this slow, fading sleep a kind of sacredness, a final rest that follows all striving, all chaos, a peace not earned but guaranteed by the collapse of all struggle. Now imagine a civilization trillions of years from now facing this quiet doom. They have extended life beyond stars, harnessed black hole energy, built artificial suns until nothing remains to harness. Their libraries, their thoughts, their hopes, dim like the dying glow of a white dwarf. No catastrophe, just stillness. Would such beings welcome the end? Would they leave behind time capsules or accept the cold silence as home? Or would they rage, refusing to sleep in a universe that no longer dreams? As you let your thoughts drift, let this image settle. A cosmos with nothing left to give or take. No fear, no desire, just perfect thermal balance. No high, no low, just eternal equilibrium. And now, we're left with the unsettling calm of the aftermath. A universe that once blazed with stars and the dance of galaxies now rests in an eternal hush. This isn't death in the conventional sense. There's no dramatic explosion, no catastrophic collapse. The end here is gentle, eerily gentle. It's a kind of existential fading, a cosmic sigh into entropy. In this vision of the cosmos, what's unnerving is not the violence of its end, but the absence of drama. Everything runs down like an old clock, ticking slower and slower, until the ticking itself fades to silence. No more stars are born. The last black holes have dissolved into ghostly radiation. Particles themselves may decay or dissolve into irrelevance. And so, the universe becomes a graveyard, not of objects, but of possibility. Every configuration has been exhausted. Every permutation of matter, energy, motion has reached its endgame. All that remains is what physicists call thermal equilibrium, where nothing can happen because everything is the same. Even quantum fluctuations, those tiny bursts of activity that seem to exist in every corner of empty space, may become meaningless, stretched out and thinned beyond interaction. There is something deeply philosophical about this scenario. The heat death isn't just a physical theory, it echoes ancient ideas of fate and stasis. The Stoics spoke of cycles, but even their view allowed for rebirth. This doesn't. In fact, some might say this is the most atheistic ending imaginable. A universe that lives, thrives, and then simply expires. Not because of sin or judgment or divine plan, but because that's what thermodynamics requires. But even here, strange hope lingers. Some physicists speculate that entropy itself might reset in certain quantum cosmologies, that a new Big Bang might bubble out from the ashes of maximum entropy, like a phoenix from invisible dust. Could the heat death merely be a lull before the next act? Others question whether our assumptions about time and entropy hold true on cosmic scales. Maybe time is not linear. Maybe entropy behaves differently at the edges of black holes or the folds of hidden dimensions. And in those folds, could new beginnings be written? For now, we don't know. All we have is this vision, a tranquil void where the echo of every supernova, every breath, every thought has vanished. A place where nothing happens because nothing can. A place that is, in every sense of the word, asleep. And that is the paradox. The universe ends not with noise, but with a whisper. Segment 9. The quantum resurrection when nothingness isn't the end. Imagine, if you will, that the universe has died. Stars have gone dark, Matter is scattered thin across an infinite canvas, and even black holes, those eternal vacuum cleaners of the cosmos, have evaporated into the void. There's nothing left. No heat, no light, not even a whisper of gravity strong enough to gather dust. But then something happens. In the silence of complete emptiness, a fluctuation, a spark, a blip of quantum energy. You've entered the strange and thrilling territory of quantum resurrection. The idea that even in a universe that has completely exhausted itself, something might still rise again. From the ruins of heat death or absolute entropy, a new cosmos could flicker into being, not by divine hand, not by design, but by the rules of quantum mechanics itself. To understand this, we need to dive into the quantum vacuum, not a void in the traditional sense, but a strange, simmering field of potential. Even what we call empty space is never truly empty. Thanks to the uncertainty principle, energy can briefly appear and disappear in the form of so-called virtual particles. These flickers are normally harmless, unobservable, ephemeral. But given an infinite stretch of time, say trillions upon trillions of years, these quantum jitters might do something wildly improbable: birth an entire universe. This is not pure fantasy. It's a possibility contemplated by physicists like Alan Guth, one of the pioneers of inflationary theory, and others exploring what's called false vacuum decay. The idea is that the vacuum state of our universe may not be the most stable one. It could be temporary, like a marble resting in a shallow valley, waiting to roll into a deeper one. If the universe transitions from its false vacuum to a true vacuum, this shift could release enormous energy, enough to spawn an entirely new universe, governed by different laws of physics, different particles, even a different arrow of time. And it might not stop at one. Given enough time, an infinite number of these baby universes could emerge, each budding off like soap bubbles in the dark. In some models, our universe is already part of this larger structure, a multiverse, a cosmic foam of possibilities endlessly sprouting from the vacuum. This concept turns death itself inside out. The end of our universe, far from being a final curtain, could be a womb for future realities. Time, space, matter. These may all reassemble themselves again and again, like notes in an infinite song. But here's the truly disturbing part. If new universes can emerge from quantum fluctuations, so can anything. In theory, you could have a fully formed brain spontaneously created by a quantum blip, complete with false memories, an illusion of identity, and a belief that it has always existed. Physicists call these entities Boltzmann brains, and they are as terrifying as they are absurd. If the universe exists long enough, the odds suggest that Boltzmann brains might outnumber actual, evolved beings like you and me. It's a scenario that breaks not only science, but sanity. If Boltzmann brains are real and more probable than evolved life, how can we trust our own minds? Are we just isolated thoughts drifting in a meaningless sea of quantum randomness? If our universe decays into a state where only Boltzmann brains remain, the lonely ghosts of cognition appearing from chaos, then our very experience of the cosmos may be a hallucination. You, reading this now, feeling your body relax into the stillness of night, may be a product of quantum chance, a ripple in nothingness that mistakenly believes itself to be real. This isn't just some horror concept out of speculative fiction. It's a serious philosophical and scientific paradox. Because if Boltzmann brains are more statistically likely than evolved life, then why are we experiencing a consistent, ordered universe with a long history and coherent physical laws? Shouldn't we, by sheer probability, wake up into confusion, into floating madness? One proposed answer lies in entropy. The second law of thermodynamics tells us that systems move toward disorder. But our universe began in a low entropy state, highly ordered, and has been increasing in entropy ever since. If we were Boltzmann brains, we'd expect to find ourselves in a much more chaotic environment, not this elegant cosmic tapestry with galaxies, stars, and physical predictability. So maybe, just maybe, our reality is the rare one that grew from nothing naturally. Not a glitch, but a story that actually happened. Still, even if Boltzmann brains are rare, the idea that they're possible is deeply unsettling. It forces us to confront questions about identity, consciousness, and the meaning of reality itself. What does it mean to be you, if there's a chance that you could be assembled randomly? with false memories of a life never lived? And now, back to the grander picture. Quantum resurrection also offers a quiet hope. For all its mind-warping implications, it implies that the cosmos never truly ends. Entropy may rise, stars may fade, but quantum fields are always there, waiting, simmering with possibility. Perhaps this is what Nietzsche intuited in his doctrine of eternal recurrence, that even when things die, they might return. Not through divine intervention, but through inevitability. Not a circle of reincarnation in a religious sense, but a probabilistic echo baked into the nature of existence. In this way, the universe is both mortal and immortal. Each ending is a scattering of ingredients. Each silence is pregnant with rebirth. And here is where God can re-enter the picture, not as a bearded watchmaker in the sky, but as the very rules of the quantum itself. A creator whose language is probability, whose brushstroke is fluctuation, whose cathedral is the vacuum. Some thinkers, like Spinoza or Einstein, imagined God not as a personality, but as the totality of laws that govern reality. In a quantum universe, that vision becomes oddly literal. The divine isn't out there, but in the tiniest tremors of nothingness, the same tremors that may one day, long after we are gone, give rise to a new Big Bang, a new Earth, a new dreamer wondering where it all came from. And so, in the dying light of our universe, perhaps there is not despair, but infinite potential. So, if we accept that a Boltzmann brain could emerge spontaneously in the infinite churn of a thermodynamic universe, what does that say about the reliability of our memories, or even the continuity of our selfhood? You, sitting here now, are you the culmination of billions of years of evolutionary history, or a fluctuation born moments ago in a cold, empty void with fabricated memories stitched into your synapses? This idea, radical, unsettling, and strangely serene, dovetails with another existential thread, the fragility of identity. We cherish the idea that our consciousness is continuous, shaped by childhood joys, heartbreaks, mistakes, and triumphs. But in the Boltzmann paradigm, all of that could be a simulation. Not a simulation created by a machine, like in The Matrix, but one created by the laws of probability themselves. Every neuron, every sensation, even your knowledge of the Boltzmann brain hypothesis, could all be the random alignment of atoms that just happen to form you right now. This isn't science fiction. It's a question embedded in the very structure of entropy and time. And here's where things turn metaphysical. Not to retreat from science, but to embrace its poetic edges. If randomness can birth consciousness, then consciousness becomes less of a biological miracle and more of a cosmic tendency. Perhaps the universe, in its vast indifference, leans toward thought, not because it has a plan, but because given infinite rolls of the dice, minds will emerge. And in that endless emergence, perhaps something like immortality is embedded. Not personal immortality in the religious sense, but a kind of quantum resurrection. This phrase, quantum resurrection, suggests that given enough time, you might come back. Not through divine judgment or reincarnation, but through the same improbable mechanisms that created Boltzmann brains. A version of you, indistinguishable in mind and memory, could spark into being trillions of years from now in a far-flung region of space. You wouldn't even know you died. Let's tie this back to Nietzsche. Nietzsche's eternal recurrence posits that everything will repeat exactly as it is over and over for eternity. Boltzmann brains suggest something eerily similar, that infinite time produces not just repetitions but countless variations. Nietzsche's version was deterministic, tied to the metaphysics of will and time. Boltzmann's is stochastic, probabilistic, but no less eternal. Could we be living in a statistical loop of recurring minds? Now imagine that God in this scenario is not an old man in the sky, nor a clockmaker deity who wound up the universe and stepped away. Rather, this God is the law of large numbers, an entity of silence, a truth not spoken, but manifested in the cosmic tendency for order to briefly rise out of chaos. This is a God that does not command worship, but instead reveals itself in the persistent reappearance of mind. This leads to a delicate question. If the probability of your spontaneous existence is higher than the continuity of your life from birth to now, then which version of you should be considered the real you? A chilling possibility arises that we are merely echoes of statistical anomalies, memories stacked upon nothing. But even then, isn't there something strangely liberating in this view? If you are a spark in the abyss, a fleeting firefly in the void, does it not make each moment of awareness more precious? After all, even if your memories are illusions, your experience is real to you, and maybe that's enough. So let's descend deeper still, into the ethics of the Boltzmann brain. If such consciousnesses can emerge spontaneously, do they deserve moral consideration? Is a fleeting, floating mind owed compassion, dignity, or rights, even if it exists for less than a second? These are the kinds of questions philosophers like Thomas Metzinger and David Chalmers have begun to toy with in the age of artificial intelligence and digital simulations. But the Boltzmann brain is not digital. It's organic in a way that transcends biology. It's made of atoms, like you, just rearranged. So, in the chilling quiet of a heat-dead universe, a single thought might blink into existence. I think, therefore I am. And then, gone. That's the most beautiful and terrifying part of this theory, the lonely awareness born into oblivion. To contemplate this is to sit at the very edge of reason, but the more you sit with it, and I mean truly sit with it in your own mind, not just as a factoid, the more its disturbing poetry reveals itself. The loneliness of a mind with no world, no future, no context, but still, somehow a mind. And perhaps that is why we fear it. Not because it challenges our knowledge, but because it challenges our value. But let me offer a gentler thought before this segment closes. If the Boltzmann brain is possible, and your current experience is consistent with what it would feel like to be one, then you are real enough. And that may be the only kind of real that matters. In that moment, right now, your thoughts, your breath, your curiosity, and your ability to hold this thought, that's a miracle in itself. Not a miracle in the religious sense, but in the entropic one. A statistical outlier, a self-aware pause in the infinite tumble of matter. And so, we circle back. Not to answers, but to a question that binds all of these ideas. What is consciousness, if not the universe briefly aware of itself? Even if only through a brain that had no beginning and no time to end. As you let this thought echo in the stillness, know this. Whether you are the product of evolution, a divine spark, or a thermal fluctuation, your awareness right now is yours. And that somehow is enough. The stars have gone out, the galaxies have scattered beyond the reach of light, the black holes have evaporated one by one, releasing their secrets into a vacuum that no longer listens. No fire, no memory, no movement. Just a boundless field of cold nothingness stretching in every direction. This is not science fiction. It's a scenario that cosmologists call the heat death of the universe. The final chapter where all usable energy is spent, where entropy has reached its maximum, and where even time itself becomes meaningless. But what does that feel like? That's the question we end on. Not what it looks like, not what happens, but what it means. Philosophically, emotionally, even spiritually. When the universe forgets it ever existed. We often imagine the end in violent terms, a bang, a collapse, an explosion. But what if the true end is not an event at all, but a fade out so gentle we don't notice it until we realize there's nothing left to notice? Let's put it this way. Imagine walking into a room where a grand symphony was once playing. Now it's quiet. You touch the instruments. They're still warm. The pages of music still lie open on the stands, but the musicians are gone, and no echo remains. You weren't there for the finale. It ended long ago. That's the heat death, not a bang, a forgetting. In this segment, we will explore what the final silence truly implies. We'll ask, is the universe still a universe when it has no observers left to see it? Does meaning require minds? And in a cosmos destined for oblivion, is there such a thing as a meaningful act? Let's begin with a thought experiment. Close your eyes and imagine a single atom drifting in darkness. It has no destination, no purpose. It is not observed, measured, or disturbed. For trillions of years, it has done nothing except exist, statically, silently. There is no up or down, no forward or backward. Space stretches endlessly around it, but there is nothing to stretch into. This lonely atom is not unique. There are countless others like it, scattered thinly across an ever-growing void, but no atom knows of the other. There are no minds left to notice, no cameras, no sensors, no scribbled notes in a forgotten laboratory. The universe, in this state, becomes deeply alien. Not because it's hostile, but because it is utterly indifferent. We can no longer say it is cold, because there is no warmth to contrast it against. We can't say it's silent, because there are no ears to hear. It just is. And this leads to a deeper question. Is being still meaningful when it is no longer experienced? Philosophers have long debated the importance of observation in defining reality. Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that observation plays a crucial role in collapsing probabilities into definite outcomes. In a very literal sense, reality is shaped by the act of noticing it. Without minds, without consciousness, the universe reverts to a probabilistic haze, where nothing is pinned down because nothing is being seen. This is where things become eerie. In this dead future, there are no humans to think back to Earth, no computers storing data, no monuments left standing, no signals left transmitting. Even light, the fastest traveler we know, has become too weak and too stretched to be useful. Every piece of memory, of love, art, war, civilization, laughter, has evaporated without witness. The story has no reader. It's a book with blank pages. So why did it matter? If a memory exists without a mind to recall it, was it ever really a memory? This is the metaphysical riddle that haunts the dead universe. In the earliest stages of the cosmos, everything was activity. Expansion, collision, fusion, decay. Stars were born and died in brilliant cataclysms. Civilizations, briefly sparked by chance chemistry, dared to imagine meaning in the chaos. But now, at the end, activity has ceased. Entropy has claimed its final victory, not with violence, but with stillness. The universe is no longer a stage, but an empty auditorium. The performance is over, the lights are off. And yet, something remains. This remaining presence, the quiet persistence of particles, of time, of space itself, becomes almost mystical in its stillness. It resists our storytelling. There is no climax, no final battle, no audience to applaud. There is only aftermath. And what a strange aftermath it is. In some interpretations of physics, particularly the heat-death scenario, the arrow of time continues endlessly into the future. Not towards something, but away from something. Away from structure, complexity, and pattern. The future becomes an ocean of uniformity, every molecule distributed evenly, with no gradients to drive change. Temperature becomes meaningless. Motion becomes irrelevant. It is the ultimate erasure of contrast and thus of experience. Yet for some thinkers, even this desolation is not the true end. They propose that fluctuations, rare, bizarre, and unthinkably slow, might eventually birth new pockets of order. Tiny low entropy regions could, over unimaginable durations, spontaneously emerge. Some physicists have playfully called this the Boltzmann brain problem, the idea that a single self-aware consciousness could blink into existence from randomness, experience a brief moment of thought, and then dissolve again into silence. It is a tragicomic possibility. The last mind in the universe could be a hallucination, a flicker of experience sparked not by evolution but by chaos. And what would this lonely brain think? Would it remember us? Would it think it was the only being to have ever existed? Would it feel fear or awe in its nanoseconds of awareness? Or perhaps this is just our final anthropocentric fantasy, the hope that even in absolute death, a whisper of thought might remain, that the light, no matter how faint, never truly goes out. But maybe, just maybe, the truest beauty of the universe lies in its indifference. It does not weep for what is lost. It does not yearn for what was. It does not cry out in grief or joy. It simply is. And in this stillness, in this final soundless breath, we are offered a strange peace. There is something profoundly humbling about imagining a cosmos that continues long after we are gone, not just as individuals, or even as a species, but as a concept. Thought itself fades. Words disappear. Meaning dissolves. And in the dark silence that follows, the universe simply continues, unburdened by interpretation. Some might find this terrifying. a kind of existential erasure, a final exile from the narrative we believed we were part of. But perhaps it is not terror we should feel, but awe. Perhaps this great silence is not empty, but complete. The end of the universe is not a bang, not a whimper, but a gentle settling, a long exhale after a life of motion. All the chaos, all the collisions, all the brilliant flares and dark tragedies were chapters in a story that never needed to be told. And now, the book has closed. Not burned, not buried, just resting. Quiet. And within this quiet, something remarkable happens. The mind that imagines it, your mind, becomes more than just an observer. You become a bridge across the void. In dreaming of the end, you give it shape. In pondering the silence, you make it sing. Because the truth is, we have always projected ourselves onto the cosmos. The stars became our myths, the planets our gods, the darkness between them, our questions. We searched the heavens not only to understand the universe, but to understand ourselves. So what does it say that we can contemplate its ending? It says that we are not merely inhabitants of time, but architects of imagination. That in a brief flicker of consciousness, we've dared to ask the most impossible questions. Why are we here? What happens when all of this ends? And what does it mean for something to end at all? Some philosophers suggest that this search, the willingness to wonder, to confront unknowing, is the very essence of what makes life meaningful. Even in a cosmos destined for heat death or vacuum decay, the act of inquiry burns bright, not as resistance, but as grace. As you listen now, you might feel the weight of these ideas gently dissolve into something lighter. The fear of the end loses its grip when it is brought close, examined, and transformed into story. And stories, after all, are how we soften the edges of reality. So close your eyes, if they're not already closed. Let the rhythm of this thoughtscape drift into the back of your mind. You are floating now, not in space, not in time, but in awareness. A single point of stillness within all that once was. The stars are gone, the galaxies dust, even memory itself has faded, but you are still here, carried by curiosity into the quiet. And as the final note plays out, not with fear but with softness, remember this: the end is not the enemy. It is the echo of everything that ever mattered. And now you can rest. The universe will keep watch. Sleep well.